Hello. Okay, so let's start. This is the first time I've ever done this. I know no one's watching right now. A few people have retweeted the announcement I made on our Goblin Loot Twitter channel. So there is some interest. There's only how many followers have we got? 53 followers on there now. And it's not very many compared to some of these 100k sites and everything, but it hadn't been on long and was steadily growing faster and faster. So I'm sure hopefully when we get some more content and some more people watching these sessions, we'll start to build this community. It's kind of an organic thing, just like the collection was. I'm going to be showing you a bit of the code base of the collection today. I promised in a previous recorded videos that I'd look more at the Python scripts that I wrote to create the collection and how they kind of started and developed. In that video we looked at the way that they were used to download metadata from another collection, an existing one, and to analyze it and see how the traits looked and so on. Anyway, let's fade up to the code base now. We can see actually that fade worked just now, and now it's not working, so that's great. So I can't show you the code base. Wonderful. Tell you what, let's try this. How does that look? There you go. So there we go. So it's all new to me. This is the code base. I hope you can see that. Obviously no one's watching, so I don't know that anyone can't confirm that they can see that. So I'm just going to pop over and take a look myself. This is just some ASCII art that I had fun pasting into the contract code for on Etherscan. It's my online identity of Nantron is my favorite NFT PFP, which is from that, so Lost Myrtos. I'm just going to, it's definitely working. I've just had a look. So obviously that's not what you're here for. I'm just, as I say, this is the first video, so if you're watching a recording, which you will be because no one's watching live, hopefully you don't skip ahead past this bit because I'm just about to start. So we looked at these Python scripts last time. The pull one, we didn't actually look at the code per se, we looked at how to use them. So you can pull down with a bit of config in this folder. So let's look at the structure of the project first. Let's just collapse this whole thing. So all the source files are in here, or all the source files are Python in the root of the project. There's a sub-project in here for the contract, which we won't look at today. That's a sort of project in its own right, that one. So ignore that. The main Python layout is the source files here, and then we've got data for configuration of different projects, and build, which is output. It's just the output for those projects that goes into the same folder, and that's it largely. So we looked in the last time how we could download a Lost Myrtos collection, which I did. Initially I downloaded the Goblin Town collection to have a look at that. The config for that was quite simple. Little JSON script here. You put 3 things in: how many tokens you want to retrieve. The name of it is just for reporting, really. It doesn't do anything. And the base URL. Now I went through last time and showed how to find that in Etherscan I could do that again at some point if someone wants me to. But yeah, then you can run the commands to pull that down. So I think it's, I'm in the terminal here for the project. So run Python source pull is the command that does that, and then the option for the project would be the subfolder in that data folder. So that's Goblin Town in this case. Let's spell it correctly, and there we go. It will read the config file that it finds in there and start pulling them down as long as you specify the correct argument. So I'm just going to say, what's the token count? Now I can't remember what the arguments from my own function are, script is now. So let's just look. It should tell me if I go help, I think. Here we go. So it's n. So let's try just getting 2 or 3, 4. Now I've already done this. If I overwrite them, it's fine. I will. It won't delete the whole folder. It will just overwrite the first 4 metadatas that it's putting down from this URL here. So they will go in the corresponding subfolder of build here. Goblin Town. This is going to take a while to open, I think, because there's quite a lot of things inside. Here we go. I've got all the metadata that I've downloaded before. These are the ones I've just overwritten. And so it's not the pure metadata that's actually on IPFS. It's been processed into a simple dictionary of trait versus the trait value, or what I've called in the terminology of this project, the trait group and the trait. So you can get lots and lots of traits within the collars trait group, lots and lots of traits within the body trait group, and so on, and these are all traits. So download all that metadata, and then you can run other commands to process it, which I showed last time. There's a report one, and what that does is analyzes all the files that it finds in the build folder. So let's just have a look at that and see if I can just show you that again. It's kind of an overview. I expect most people watching this won't have seen the last one anyway. So P, report P, Goblin Town, and obviously I did it with the Lost Murtos collection last time, so it's fun to see it with the Goblin Town one as well. Let's just make this bigger, this part. I'm doing it all within VS Code this time, so I don't have to swap between different windows and so on for the live stream. It's quite handy, VS Code, for all sorts of things. You can see it's printing out all sorts of stats here for the based on the metadata that it's found. So we've got, for this trait group, we've got all the traits that exist for that trait group and how frequently they appear as a percentage. So the stupid sun is the rarest one, and in this case the boom body is the rarest one. The most common is flappy, and so on. Then we've got just say 10 or so of the most rare ones and their number. This is just based on a really simple rarity score of the count of how many times that trait appears in the whole collection. These are one of ones, each of which only have one of the traits, so they're all 1, so they're all at the top. And then if we go down, we'll find the first, well, these eggs. These eggs, there's only 5 of each one. there's only 5 tokens, therefore, that have that, so there's 5 eggs there. And then the next one, 1914, this has got a score of 233. This is just based on the fact that this particular token has traits in each of the trait groups that appear the least amount of times in total across all of them. So it might not be the rarest of each particular one, but in taken in the total, that score becomes the lowest. I don't know whether that's the scoring system that anyone else uses, but it's interesting anyway. It's a bit of analysis on the data there, so we can see they are rare. I mean, they are rare. Whether they match rarity for sniper and all those sites is another matter. Then I've got more of a breakdown here. So I've got 5 eggs, 12 1-of-1s. They're both unique, which means that they don't have other traits in them, whereas these are all it means these traits only appear in one token, whereas these traits appear all over the place. And you can see that the majority of the collection contains them. So 99.8% of the collection contains all these trait groups, or equally. There's none with any missing or anything in this one. 9,982 of them. There's 14 collars, 25 bodies, 21 ears, and so on. And then we've got rarities of each particular trait. Doesn't matter what group it's in, it's just the rarest trait. So those are all the same, all those 1-of-1s. And then the 5 eggs. And it looks like the laser eyes are the rarest trait after that. And they're on that side, trait group. And then butterfly ears on the ears, and so on. The most common, least rare, is the Cobalt Puke collar, apparently. There you go. There's 850 of those in the whole collection. So bad luck if you minted one of those. Well, no, actually, I wish I had minted any of these. I hadn't, so there you go. Anyway, I was interested in this collection in particular because it did so well, and I read something somewhere that said it had a good trait design, and I wondered what that meant. Really, how do you go about designing traits that for a collection? How do you do that? So I thought, well, I'll analyze this, see how it all hangs together, and then obviously that was all scripted, so why not use scripts to generate a more generic profile of this apparently good trait design to create a new collection, which I did, and that's what Goblin Loot is. It doesn't copy any of the content, it just copies the rarity profile, the figures, the percentages of each, how many trait groups there are, how many traits there are in each one. And it doesn't put them all in the same tokens, it randomizes that just using the rarities, making sure that there's still the same number of each trait in each group, but that they are distributed out through all the tokens in a completely different way. So that is the main subject of this video, and that's the extra scripts we didn't look at last time I'm going to look at now. So in the build folder for Goblin Town, got all those metadatas, and at the end we've compiled them all into one with the script again. And this file, all traits JSON, is just an array of all of the other ones, and so it's just an array. That's how you do the array. And this is the object. So this is JSON. If you haven't seen JSON before, it's pretty simple notation. We've got an object. An object has to have keys inside it that are strings, and then they can have all sorts of different values. So there's a number there, a string there, and then you can have other objects as well. So you could put another object in this, just for the sake of argument. I'll undo this, but you can take this object and you can say, okay, say it had a child token, which is mad. It wouldn't, but it's just an example. There's the child token now. That's a bit messy. In Visual Studio, you can control KD. I was thinking there because it's quite a big file. Maybe I shouldn't have done that, but it will indent it all for you nicely and everything. But the structure is there. You've got another child, and inside there the child has the same rules of the syntax of this data structure. And then also you can have arrays, and they've just got the square brackets, and then inside there you've just got a comma separated list of strings or objects or numbers or whatever. That is going to take a long time. I probably shouldn't have done that. So if I try and close that and not save it, it will stop trying to do that. So let's just make this terminal bigger again. The rest of the scripts operate on that JSON we just looked at that has all the traits inside it. It looks like the formatter is still going, so that's not so good. Let's keep waiting because I'm recording this window. I don't want to close it. Here we go. Right, that's kicked in. Right, so note to self: don't try to auto format a 10,000 line JSON file. That is not hand-edited file. You wouldn't really want to ever be hand-editing a file of that size. That's a generated file that kind of never open. It's just there for the other scripts to read. I generated with the scripts as well a profile and a remap. What they are, I can show you how to do that as well. Is well, we can look at a bit of the script if we want to get into Python. So this is the pull script. Let's look at the salient parts. It's quite small. If you haven't seen Python before, it uses indenting to do all the scoping and everything. It's quite easy to learn, but it's quite different from other languages like JavaScript, which use brackets to do that. So Visual Studio really does help you. If you do anything wrong, it highlights that, so you can quite easily get hints and things as well about what things are. And the IntelliSense is very useful. So this part of it just gets the options. The options are set as the project, which has an argument, which is what the colon means. The H is just doesn't have an argument, so there's no colon after it, which is the help. So that's how you get the help. Number of tokens, and then there were two other things I didn't show, which is you can, if it's say for that you wanted to get all of them, but if it fell over, it broke, or the internet went down, it would stop, and then you can just start again at a different starting place. So you got to 100, you can start at 100 and carry on. So that's then uses these options to find the build folder, which is because we've got a consistent structure to that, it knows where that's going to be, and that This is where it makes the all traits JSONs. That's the name of it there. So if we just search for, if you were coming to this code base blind, without me explaining it all, and you saw the all traits JSON there, you could search for this, and you could start using that as the point of, oh look, this is how it's made. This is your sort of into discovering about how this works. I wanted to show you, the reason I came in here, the compile option that makes the all traits JSON. So what this is doing, without going into too much detail, if you're new to Python, it might just look completely bewildering, is it will print out this message, which is more or less straightforward. And then this part is looking for things in here. So what this does is it lists out all the files inside the build folder, and we know it's just got these. At the point that this was compiled, it's just got these. It looks to see if they end in JSON, which these do, and then let's see, let's just do it. Let's delete these ones because I don't want to include those, and they're generated afterwards. I mean, this is quite a ad hoc, thrown together code base. You would probably have subfolders for the metadata and so on, and organize it a little bit better, which we can do. We can improve on this, just a starting point. Sometimes you don't need to go to that level of kind of detail. You don't have to make everything perfect just to get something working. I mean, I launched the collection without refactoring that part of it. It's fine. So that's going to take a while to delete. Again, you probably should have deleted that inside Windows Explorer rather than through the IDE, because it seems to. But I'm getting a new computer soon as well, so that will help. This is quite an old ThinkPad that I'm working on now. Getting a new one soon, so hopefully these things will go a little bit quicker in the future. So I'll just wait for that one. This is very slow. It's just deleting files. It really shouldn't take that long. So let's show you how we compile all those into a single all traits JSON using the script. While I'm waiting for that, one of the reasons I wanted to start this whole thing is because I like how I work. I've been a professional developer for over 24 years and work with people all the time in a kind of closed community of the workplace, the office, and how the staff members there who I work with, my colleagues. We all discuss things and we all work on things, and all those things are proprietary code, and I haven't got a GitHub that I can share those on. They're all secret code and I can't talk about. So it was I wanted to make a new project that I could just put on GitHub and talk about and make videos about, and also have the same kind of conversations that I have with a few people, helping mentor younger coders and so on. But I make that available to everyone, and share some of my experience with anyone who is interested in learning to code. I'm mostly focusing on complete beginners who maybe have an interest in NFTs, maybe just started college or whatever, and they just want to learn. It doesn't matter race, gender, or age at all. Everyone can start learning to code, and I think if you do, you just especially in the NFT space, you can start to get a bit safer. You can start to learn how things work. You can avoid those scams. So that's finally deleted those. We've got this function. It's going to list out all these JSON files inside this folder here, and that's an argument to this function, which filters them using this rule A lambda is just a little function inside here, and the rule is that this is going to be called, this function is going to be called for every single thing it finds in this, one after the other. And this is the file that goes around it. It's like a little loop. It doesn't look like a loop, but it is. And what this is doing is it's giving you a file and saying, give me a true or false. If it's true, I'll include it. If it's false, I won't. So this function says if the file ends with JSON, return true. That's what that bool is at the end there, true. Otherwise, return false. And there's some handy pop-up text telling you what it does there. So it will only end up returning from this a list of all the JSON files in that folder, and then there's some Python shenanigans there that actually turn that into an actual list that it can use to go round. And the way we go around that is like this. So for each file in the meta, which is what I assigned that list to, called it meta because that's what it is, it's metadata. I load the JSON file. Now that's a helper function that I've written, but it's quite a simple one. What I did there was hit F12 on it, and it goes and if the file's not already open, opens it, and it puts the cursor exactly where that's defined. Central, that you learn all sorts of really fast tricks to navigate around these code bases. They can be really complex. They can have thousands and thousands of files in different subfolders, different projects, all over the place. And you can't go searching for them normally by grubbling around inside the Explorer and searching for things. You need to be able to go straight to a definition and go back again and everything. So it's and search for things. That's key. Learning all the keyboard shortcuts and fast navigation around the code base is just going to enable you to focus on the more interesting things. So, which is what I'll do now. It opens the file into a file and then loads the file as JSON and returns it to you as a Python object, a Python dictionary that you can use in Python to read all the data that we saw in the JSON file. In this case, it's not interested in really what the data is. It's just putting each of those dictionaries into another list, which is all the tokens, and then it opens the all traits JSON and makes a new one as a write. So it's writing to a new file called that. And that's as is just how we refer to that file. So now this function is going to return like a handle to the file called that, which we can use in other places. And in this case, we're using it in this as an argument to this JSON dump folder, which takes 3 parameters: the list to dump, which we've just made, the file handle to stick it to, which is that one we've just opened, and the indenting on there, which I've put as 4 spaces. So it does that all in one go, and when that comes out, the file automatically closes. That's what with means. Is everything inside here, this is going to be open. As soon as you come out, it closes, and then we just exit. This is just a way to exit the script, so we don't run the rest of it. We don't want to do that anymore. This is the option that just does this and quits. So the compile option is -C. It's that last one that I didn't mention. So it should be usually when help commands, when you see these brackets here, it means it's optional. So you need this one, but these are optional. So I just need, I should put that there actually, the project and -C to compile all those JSONs into the all traits, which you should hopefully see appear on the end there if I run it. So py source Goblin Town WTF minus, oh no, that's not right, is it? It's poll py minus p Goblin Town WTF minus c for compile. Which should print the message that we saw. There we go, confirming that that build folder is the one we wanted. And it's going and doing that. It's loading them all into memory, as we saw, and will eventually write it all out as that big 10,000 line JSON file that we saw earlier that almost destroyed VS Code when I tried to format it. So that could take a while. If I had my new computer, it would not take quite as long. But it is certainly going to be a lot quicker than trying to do it manually, especially if you've got even more files. Also, I mean, I can go away and do something else now. I don't have to sit here watching it. So this automation is just critical to performing well as a coder, and you can automate all sorts of things once you know a few bits of Python, a few terminal commands, and how to use the terminal. There's so many fast ways of doing automatic things that are quite easy. That a lot of people just aren't brave enough to learn the technicals. They'll just go ahead and do these things manually for the rest of their life and just waste time just manually doing things because they haven't tried to learn the automatic way of doing it. I suppose not everyone's technically minded, that's fine. It's up to the rest of us to help them, giving them tools and giving them ways of letting the computer do all the hard work and letting humans focus on the fun stuff. Live stream's been going for 34 minutes now. I'm going to carry on until I'm done showing you what I wanted to show you. Obviously, if you're watching this back, you can skip around and so on. That's taking quite a long time. So let's leave that. As I say, I can just run in the background. It's fine. And look at the report. So the report takes that all traits when it reappears again. I could stop that and just bring it back because it's all checked into GitHub. I can get that back out again. All those files I've deleted. So this is the script. You can import various things up here. This is parts of the Python kind of ecosystem that you might want to use. Some of them come with the Python. Some you'll have to install as little packages. That's what the py cache is up there. It's oh, there we go. I've run commands on the command line, which I could show you at some point, to just install little other utils that don't necessarily come with it, and you can write your own ones as well. So these scripts, that one I showed you there for loading the JSON, actually it's not that one, is it? It's load. You're just making a function like this, def, that's how you make a function, that's the name of the function and any parameters it takes. That's saying I've done that now, this is the rest of it, this is the body. That is in load py, so when I'm in here I can, it wasn't poll, but it was report we were looking at, so double click that. I can, from load, which is just the function, the file, the py file there, import load JSON, which is the function, the def that we put in there, in exactly the same way as you would for a tool that you installed. So then I can use that and share that in other places, and that that's what I'm doing there. I was going to show you something else then, but it's not actually in this script. So we've got the options for this one. Project is always there, and then we can, if we don't put these should actually, if I'm being consistent, these should have the square brackets around them because they are optional. If you just run it like that, as we saw earlier, it prints out all that information, which when I ran it last time, I actually piped to a text file. I can show you. I think I showed you that in the last video. Is you run a command, it all spits it out to the terminal usually. But if you use a little right arrow and then the file name, it spits it out to the file name instead. And that's what that is. That's what I've done there. Last time it all came out to the terminal. If I put an arrow and then report.txt in the build folder, it all saves into there. So that's what that's done. So if you just do that with just that's what it does with just the P. If I put X or R, which you can put together, it does something different. Where's that? You've got options export. So if we look for options export in the rest of the script, so there's a bit of error checking there. If we haven't given it the project, it says that and it quits. It's quite straightforward, that. So that's a little check that I commented out that I was looking for all tokens that are unique. It was a bit slow and I didn't want it any more, so I took that out. That's saying if it's false, so if we put export, it's not going to be printing all this stuff. It's still going to be processing it. It's a bit of a sort of hacky script and just saying, oh, just don't do this, don't do this, don't do this. I probably should have made a different script, to be honest, to do this. But at the end, what we're going to do is print out a remapped version of the all traits that just has, instead of the actual trait groups, it's just got group 0, group 1, group 2, group 3, group 4, group 5. And instead of the actual traits, like the color types and things in the Goblin Town, it's trait 0, trait 1, trait 2, trait 3. And they're just named uniquely. So all the traits, individual traits, have got a unique name. Where it doesn't matter what group they're in, there'll never be another trait 0. You don't have the group starting with trait 0 every time. It's unique. And then so that gets rid of all the actual content, but keeps how many traits are in each one. And then the remap file, it's just a dictionary, a flat dictionary with of JSON again, and all the keys are those group 0, group 1, group 2, and trait 0, trait 1, and so on, with the names that they were. And then what you can do is you can go in and you can change all the names to something else. See? And then if you want to generate all your tokens, you can take the profile, which is all the group 1, group 2, group 3, and use that map to put those names back into it. And then you've got all traits, that is all the traits for your new collection. And then there's some scripts to make the actual JSON metadata for the new collection. You can make as many tokens as you like out of it, but obviously the profile is designed to work with 9999, so you make another 999 collection, and those will all be used to create the new collection in different orders to the original one. It doesn't care, it doesn't save in the profile what tokens had which ones. It's just a profile of rarity. So that's actually just finished. So if I open up the build folder, I've got the all traits there again. So it's just made that. It took a while, but as I say, we did something else while it was doing it, so it doesn't matter. And then we looked at the report here. This, if you don't know, is showing that these aren't saved. It's because I've changed those option strings to the help text in those. So I'll save them. Why not? Let's save those. There's some good changes there. And then I'll run that report with those extra arguments. So let's py source report py. Oh, I'm probably going to try and keep these videos a bit shorter. I can actually go on forever talking about this stuff, but you probably don't want me to. This is, as I say, it's the first time I've done this, quite new, but it's familiar territory in terms of at work. I'm usually doing this with someone sitting next to me, but here we can all do that. Anyone who's interested can do that with me. Hopefully, as we go into the future, we'll have more people watching live. Well, some people watching live and asking questions, and that'd be great. So minus x r, I think you can do that, but let's just do that because I've done it in the past. I know it works. We'll create these two files here. The scripts is a little bit more complicated than the all traits one. I think we don't want to get into that now. We can look at that, maybe each one of those perhaps in its own video. But what it's doing is what I described, which is the profile with all the names stripped out and the counts. So you've got total 9982. You've got the groups here, and in each group you've got the traits and how many of them there were. That's the crucial thing there. You can collapse these bits here. So I can collapse group 0 here, and you see it. There were 14 traits in the other one. 14 because it starts with 0, so it goes down to 13 there. And then it starts with 14 in this group 1, 15, and so on, with the various counts of how many times that trait appeared in the whole collection for that group, and so on. So go through all these groups here. Let me just collapse that one. And 5, 6 groups, 7 groups, 8. Now it's grouped those groups into its own group here. That's why the total was 9982, because those are unique false. Now they all appeared together in the token. So they all appear when you want to make. You've got to make 990. So what it's saying. This is what the profile is saying, based off of what the design was for Goblin Town. There were 9,982 tokens with all these groups in them, and then there were 5 tokens which only had this group 8 and trait 181, which is in the collection is egg and the Missy text, which I'll show you in a minute. And then there's 12 one of ones. They've only got 1 of each of those traits. Those traits only appear once, and they're all one of ones, and they're unique as well. So they won't all appear together in one token. It's looking to make 12 of those with only 1 in each. So group 9. So we'll look at let's look at group 8. So group 8 And this is the other file I was speaking about. It's the remap. It's a flat list, flat dictionary of what it was and what its name is. So if I look at group 8, that was the egg, and trait 181 was that Mistress Eggy thing. So what I did for Goblin Loot collection is take this profile and map. Let's close this. And I went and I had a little think, and I was playing around with all sorts of ways of generating metadata prior to this. I was generating combinations of words and things like that, and trying out. But it's a bit more creative if you do them all manually, actually, rather than trying to generate that. But I took that remap file. This is the output folder for Goblin Loot. So I took that and put it in the data folder for Goblin Loot here. And gave it my things. So we've got the group 1 is now foods, and it's got the 14 traits of food. Rotted bread, sprouted, I've done it in Goblin speak. Putrid gruel, stale bread, withered carrot, turnip, and so on. And I called that Dragonburger there. The reason I highlighted that is because we look at trait 7 for the Goblin Town collection here. These metadata really should be in a subfolder. It's quite unwieldy. Maybe that's an improvement we can do a live coding session on, how to do that. That would be quite a simple one, just to show you how you can take an existing code base, which is what you would do most of the time. If you start a job, you dive into all sorts of existing code. You never start from scratch, and you get tasked with making a small improvement like that, like make sure all those go in a subfolder. So you look at the trait 7 in this one. Search for it. Trait 7. Cobalt Pew. Some of them are capital. I've tried mostly, I think, to mimic that. I didn't in that case, but there's laser eyes there. So look at laser ears, laser eyes. I don't know. Trait 56. I think once I started getting into it, I started noticing that and doing that. And then I think I came back and reapplied it to the first one, but just put it in the wrong bit. Very poison. There you go. So they kind of stand out. So I tried to make mine stand out in this largely the same way. And then I'm not going to scroll down and show you the 1 of 1s because they haven't been minted yet. Only one of them has actually. And then there's an extra trait that I used for egg, which no one's seen yet either, because that hasn't been minted yet. I know what's going to be minted because it's all the metadata is completely defined already. I've run the script to generate all the token JSONs here, uploaded them to IPFS, and then wrote the contract to point to those. This is a learning collection. It's fun. People have minted a few. It's quite nice and gratifying to see that happen, and it'll work. It's not, the collection itself isn't really there to make money. If it gets to 5,000, that starts being not a free mint, because it would be nice to have some money to play with for this project. Let's see how it goes. I could potentially build this and get some more people on board and build a team and have people that are perhaps more expert in other languages that can help. I'm not an expert in Solidity. I managed to write the script and learn it, and then publish the contract fine, but it would be better for someone who had more Solidity experience just to talk about that. I'm primarily going to be talking about actually TypeScript and React and JavaScript. Python's relatively new, but because I'm quite experienced coder, I picked it up quickly. It's very similar to lots of other languages I've used in the past. And it's a better language for dealing with this kind of thing, more so than JavaScript, which is better for web and some server code if you've got a Node.js server and so on. So anyway, I diverge even. So I remapped all these, made groups, made my traits, and used the profile to generate all these metadatas. If I click on here, let's just hope it's not one of those rare ones, and you'll get a sneak peek. Yeah, no, what I was going to say is I did have a proxy on my contract that would only allow you to see the metadata for the ones that had been minted. That is something I would have had to pay for. I'm not making any money yet on this, so I couldn't really pay for that. Once it was live, it didn't scale, didn't timed out and everything, so people weren't seeing their metadata and their images. So I just set that to the base URL of the IPFS where I uploaded all these JSONs to, which means you can just go ahead. You can go on and onto the Etherscan contract. You can look at the URL and you can snipe all the metadata. You can see all these. You can look into all of them online right now if you want, and find the ones and what number they're going to be. That's not what you usually do. I probably do a reveal in the future, but I want people to learn how to do that. I want to teach people how to go on and do that and find those things out. So it's intentional that those can be sniped. And as I say, there's no budget for putting a proxy in or doing a reveal, and there's no marketing to build up the interest and mint quickly and all that kind of thing. So we'll mint out eventually as this project grows, I'm sure, and see those tokens appear in people's wallets. So yeah, how was it made? That was with the generate by profile script. This generate was scripts for the original way I was thinking of doing it with the custom text, but this one is generating by the profile. I won't run it now because it takes a long time, and I'm going to draw to a close soon. It's definitely, I don't want to go over an hour on this. Got work tomorrow for one thing. And I need a glass of water, which, note to self, I will make sure I've got before I start next time. So we can talk about that next time. The options for this one, it takes the all trait. It just takes the project. There's a function. You can't see that big list of options because it's just using this one here. Options. This is a generic one. It just takes project and number of tokens. So I tell it what project I want, how many tokens I want to generate. It makes the build folder, makes it if it doesn't exist, reads the all traits from there as well, and then it goes around in this code, taking things out from the profile and the remap. There's all these functions here. Goes around a loop of how many you want to make, making sure they're all unique, and putting them into tokens, one-of-ones, eggs, whatever they were, and all the other ones that share the 6 trait groups or 7 trait groups, with just random numbers to look them up, and sort of reducing those counts down every time, so that once they get to 0, they're not used anymore. And then you've got your new tokens that have exactly the same rarity profile, as Goblin Town, which is what Goblin Loot is. I'll stop there. We can look into more detail in this, and we can run those scripts to make other collections and so on. But that is how Goblin Loot was made in terms of its metadata. And I will show you how to do the images for NFTs in a future session. The images, just briefly on this one, were if you haven't seen the Goblin Loot collection, are just strings. It's just a text collection. So they're just the font. The font I use on my logo is the Goblin Loot is what I want here in the images folder. I've got them all in subfolders, so they're easy to navigate. So this is an improvement I made on this one, and I've got them all because I was interested in not being able to snipe the images, although you can from the metadata now. They've all got random names so that you can't really know what number they are. Lots of stuff I can do sessions on in the future, and it just makes images like this. This is generated, but I can show you, and I'll have to put some things together where how you can actually make like a PFP from bits of image and lay them on top of each other and so on as well, based on the rarity in that token, or based on the traits that are in that token. It just looks up file names and so on of images and puts them in here and lays them on top of each other. I've seen bugs in other connections where that goes wrong as well. So there's detail to work through there, but that's the general principle of how that works. So there's a lot to look at. If you're watching this after the live stream's finished, please do comment. Please like, subscribe, share. I've got links to Twitter, which is my main community. There's a link on there as well on Twitter to the website where you can mint this collection. It's still free. It's an ERC 271A contract, so it's really efficient on gas. You can do 20 at once. There's no wallet limit. If you just wanted loads and loads of random images of text, then go for it. In the future, hopefully we'll have holder benefits. We'll have a Discord where you can only get into channels where I can maybe help you with coding problems in there if you're a holder. I don't know, that's an idea, but it could do double duty, this collection, not only as something as a talking point for education, but also as a way of having membership in the community. We'll see. Anyway, for now, please do go to Twitter. Please follow us on there for more updates, and follow us on YouTube as well. Thank you very much if you have got this far, and I hope to hear from you soon. I'd love to hear what you're doing. It doesn't have to be Python, doesn't have to be any language at all. Anything you're working on, doesn't have to be NFTs. If you're a new coder or have been coding for a while but just want to ask some questions from an old coder who's been around the block and knows a few things, then I'd love to talk about it and give you some thoughts and maybe help. All welcome, and I'll speak to you next time. Thank you very much.